resistor?
2.987 volts peak to peak.
2.987
7.
peak to peak. Okay. And then voltage across your inductor.
281.5 millivolts.
And then our IT.
298.8 microamps peak to peak.
298. What?
0.8.
0.8.
Yep, 7.
Okay, then your X of L.
943.5
Okay.
10.04 k ohms.
Yep.
10.04.
Yep.
Okay, then your theta.
5.384.
384.
Yep.
Yeah, that should be positive. All right, so then you can see that our, I'm not going to write them all in because I don't have enough room on here. But as we start to increase on our frequency, our angle is going to start to increase as we start to increase our frequency. And so, and also our X of L is going to start to increase in resistance, and our current is going to start to go down as we go through. So let's just go and jump right down to 100 kilohertz. So 100 kilohertz, what did I get for my voltage across VR? 471.4 millivolts peak to peak. Okay, and then my voltage across my VL.
2.963 volts peak to
And my IT.
47.15 microamps.
47.1515 microamps peak to peak. Okay, and my X of L.
62.83 k ohms.
38 kilo ohms.
83.
And my impedance.
63.62 k ohms. 0.62.
Okay, and my angle.
80.96. Possibly.
0.96. So you can kind of see those, as I start to increase my frequency, VR starts out very high and then goes very low. So here's my frequency. So when we're doing our frequency response chart, my frequency, as I go this way, I'm increasing my frequency. So at my low frequency, my VR then starts out to be very high, right? So my VR starts to go up very high, and then what happens is we're going to get a curve that looks something like this. And here's our VR. And then as I increase my frequency, then VL is just doing just the opposite. That one's starting out very low and increasing and becomes very high. So as I increase my frequency, what happens to my angle as I start going to higher frequency? My angle increases. Okay? And it becomes closer to VL then as we increase our frequency. And then right at this point here, right where these two intersect, what do I call that point?
Frequency cutoff.
Yeah, my cutoff frequency. And that happens at what angle? 45 degrees. And this is on a RL circuit, it's going to be a positive 45 degrees. So how do I calculate out my frequency cutoff? What happens at 45 degrees? What are some of the characteristics of my frequency cutoff?
XFL.
Maximum power.
Yeah. X of L equals R. And what else happens?
You get your max power.
What's that?
Max power is there?
My half power.
Half power.
Yep, that's half power because half my power is going across my inductor and half my power is going across my resistor. So another term for frequency cutoff is that I'm at half power. Good. And that's our big term that we use. That's typically where we get our maximum power transfer too. That's when we get our maximum amount of power going across either one of our components. Okay, so X of L equals R. Some of the other ones are PL equals VR. PL equals PR. You know, all those component values are all equal to the same. Plus 45 degrees. I'm at my half power. So how do I calculate out my frequency cutoff then?
Oh, crap. I gotta go back.
So,
R divided by 2 pi L.
go ahead.
Resistance divided by the 2 pi and the capacitor.
Yeah, I got two people talking here.
Go
Sorry.
for it.
Okay, go ahead. So go ahead, Mindy.
Frequency cutoff is the resistance divided by 2 pi and the capacitor. 2 pi L.
2 pi L. Yeah. So basically all it is that we're really actually, since we know that at 45 degrees, X of L is equal to R, so X of L here is just replaced with R, and then what we're doing is that we want to leave frequency by itself, and so we're just taking our 2 pi L and dividing it by R. And then that gives us our frequency cutoff, and that's going to leave us the remainder of what that frequency would be at. So what's going to be my frequency cutoff then? So what is R equal to then? Yeah, 10,000. So I'm just going to take 10,000 and I'm going to divide it by my 2 pi L.
Kilohertz.
Yeah, frequency, right?
Yeah.
So somewhere right in between where you calculated out your 12 kilohertz and your 16 kilohertz. Your 12 kilohertz has been something slightly less than 45 degrees, and then your 16 kilohertz has been something a little bit more than 45 degrees. So you know that your frequency cutoff is somewhere right in that area.
That should be almost 45 degrees. That's going to be almost 60.
Okay, so you should always know. So if somebody asks you what's your frequency cutoff, just look and see what the value of your resistor is, and substitute it in your formula. You can always calculate out your frequency cutoff. All right, so basically then what we have is these. So now what we're doing is we're using these are very simple, either high pass or low pass filters. Okay, so we might have a circuit where we only want certain frequencies to be allowed through, and it all depends on which one you're going to be measuring across. You're going to either measure across your inductor or your resistor when you're using these things as filters. If I only want low frequencies to be going out of my output, so here's my output right here, that's point A, that's my output. If I'm measuring across my resistor, if I only want low frequencies to be allowed into my circuit, I'm going to go across my voltage of my resistor. And what's going to happen is, so if I have my the circuit here. So what's going to happen is that we're going into and we're going to have all this function generator is just serving for anything. This could be in an antenna, you know, and we're bringing in signals and we want to filter out, start doing some preliminary filtering first. We want to filter out certain frequencies, and we just keep on bringing it into different stages. So the function generator is not the device that we're going to be using when we're in our application. It's just a way for us to do testing, the testing of our circuits and stuff. It's going to simulate something that's real world. Then what's going to happen is that we're going to be coming out of our output, and we're going to go into some kind of an amplifier. And then this amplifier is going to have some type of a reference voltage. And this reference voltage is going to be set at what voltage do you think, what's my voltage at this point right here? Well, what's my voltage equal to?
0.707.
Yeah. So my voltage at this point is going to be equal to 0.707 times my voltage source. So if I have my 3 volts, what's 0.707 times my 3 volts peak to peak?
.121 volts RMS.
Yeah, one more time.
2.121. 1, 2, 1. Volts RMS.
peak to peak. So that's 70% of my voltage source. So what I'm going to do is I'm going to set up a reference voltage of 2.121 volts peak to peak on my amplifier. And what's going to happen then is any of these frequencies, any of my lower frequencies that are above, so since I'm measuring across my resistor, any of my voltages that are higher than my reference voltage of 2.121 volts are what's going to go into my amplifier. And I could have, you know, this could be, you know, I might have a, what we call a feedback resistor. You know, I might get a gain of 10, you know, so now whatever this is at, I'm going to get a gain of 10 and I'm going to start amplifying my signals. And the only signal that it's going to amplify is ones that are greater than the 2.121 volts peak to peak. Anything less than that, this op amp, or what we call our operational amplifier, is going to reject anything else. If all of a sudden this voltage, if all of a sudden I end up going and setting my function generator here, and I set it up above my 15.292 kilohertz, what's going to end up coming out of my op amp, since it's not going to meet that threshold of my 2.121 volts peak to peak, it's going to be below that. And what's going to happen is that my op amp is just going to automatically reject those signals. Even though those frequencies are still coming into here, it's going to go into that op amp, look at what the reference voltage is, and say, nope, you don't meet that threshold, you're not high enough, and I'm going to just bring you down to 0. And so it's rejecting anything from 15.92 kilohertz on up. So this one here gives me for all my low frequencies, anything from 15.92 kilohertz and less. Then if I want to do the opposite, then if I want a high frequency, if I only want to filter out higher frequencies, then I just put my 2 components around. I put my resistor up here, and now I measure across my inductor. Now my inductor, as I start to go up, nothing's going to happen. It's going to reject all the signals up until it gets to the 15.92 kilohertz. Now I meet the threshold limit. The voltage of that exceeds the 2.121 volts peak to peak. And it says, okay, now you're above that frequency. Go ahead and amplify it. And then it might amplify to, you know, now it might be at, you know, 10 point something, you know, give us some kind of amplitude and keep on amplifying our signals until we come out of our speakers and stuff like that. So we can have our high pass and our low pass filters. The same thing that we have in our C circuits. The only difference is that they get kind of, the components get flipped around, but we can have a low pass and a high pass filter depending on what component that we're actually measuring across. And so those are our different filters, and that's how we can filter out certain frequencies. If we're trying to eliminate certain frequencies, you know, we might be, you know, going through across our inductor or across our resistor. Let's see here, what else do we have? Yeah, so then what we're going to find out is that, so then next week we're going to start on chapter 13, and what we're going to find out is that since the inductor acts just like the opposite of a capacitor in the circuits. So remember when we're looking at our vector, we're going to have ER here, we're going to have DC here, we're going to have VL here. VL and VC are going to be 180 degrees out of phase with one another. And what's going to happen is that this inductor is going to induce a voltage, and this capacitor is going to absorb that energy. And then depending on what the frequency is at or where it's at in the phase, then the capacitor is going to put the energy back into the circuit, and the inductor is going to have the opposition to that. And so those two are going to end up canceling out. We're going to take a combination of the VL and DC in our circuits there, and what's going to actually happen then is that we're going to get, now, instead of being either a low pass or a high pass, now what we're going to get is we're going to get a band pass, and we're going to be able to filter out
H563.
frequencies on either side of that. And the only thing that's going to be our allowable frequency is right at our frequency cutoff. So that's what we're going to try to lead up into for getting into 13. But you can see that, the RL circuits are very similar to the RC circuits. There's not much difference. The only difference is that we're just working in this part of the vector. Okay? But now we kind of took it to the next step. Now we're starting to understand what a filter is. And then in 13, we're going to really work with a lot of filters, the different types of filters, bandpass notches and stuff like that. All right, any questions on any of that stuff? I mean, it's pretty straightforward. Even chapter 12 even the reading was a lot less. But the power factors and all that still all stays the same. So we're not going to have any. We're not going to have any quiz this week. So we'll have 4 days in lab. So it'll be a good week to get it all caught up. So chapter 11 needs to be done by this Friday. So make sure you get your labs caught up. So all chapter 11 has to be done by this Friday. Otherwise, we're late after this Friday. So you got, and then we'll do chapter 13, and we'll probably spend 2 weeks on. I don't know, but we'll have to see. But we'll probably spend a week and a half on chapter 13, and then we'll do chapter 14. We'll probably actually make it through transformers on this class. So, and then we'll get ready to winter break, and then we're off into solid state. And we put the AC stuff behind us.
Oh, yeah.
Except that it comes back and on us in solid state, but not quite to this extent. All right. I don't have anything more unless you guys have any questions or anything like that. Otherwise, I don't have anything.